Today's class we're going to discuss about a real-time protocol, it is RTP, real-time protocol basics, real-time protocol packet header fields. So what is RTP? As you know that it is a protocol for real-time conversational applications. Real-time applications, as you know that voice over IP and video conferencing, it is a very popular applications over the internet. There are two standards bodies are working for real-time application. So one is IETF and another one is ITU. So, International Engineering Task Force and International Telecommunication Union. So that is it stands for. Both standards, that is IETF and ITU, they are enjoying the widespread implementation in industry products also. So whatever the industry's products which are developed, which are related to the real-time conversation applications, so that going to adhere. So these standards, so that is RTP, the protocol if it is used. So for popular applications by the industry people also. So this RTP can be used for transporting the common format such as so MP3 for so the CD music or sound quality format, even MPEG, so moving pictures expert group for videos. So it is a moving pictures expert group video. It is a sequence of images has to be recorded or encoded in the format of MPEG. It can also be used for transporting the proprietary sound and video format. So many that is sound formats are available. So other than MP3, so that is the AVA format. So that is FLV .FLV format. So the file name .extensions. So they are providing. So that is all. So that is audio format and video format also. That is the MP4 format is available. So MPEG version 4 format is available. So AVA format is available. So these are the various other formats. So it can able to transport very easily with so transporting in the sense we can able to so effectively we can able to so play out. So it is a conversation is possible, or we can able to sender between sender and receivers. We can transport very easily or transmit very easily. So these kind of formats. Again, today, RTP enjoys widespread implementation in many products and research prototype also. So we will see what are the different, so that is the payload types supposed to be used, and the products also, many products which are in the industry and research prototypes. So normally they are developed with the help of RTP. It is also complementary to other important real-time interactive protocols such as SIP. It is a session initiation protocol. So we can establish the session between caller and callee very easily. So even SIP protocol, session initiation protocol. So it is exactly again real-time protocol. It is has been run over the top of UDP, user datagram protocol. It is at the transport layer. It is exactly towards this real-time transport protocol. So RTP specify the packet structure for packet carrying audio and video data. So basically, so it is defined under request for comment. So RFC 3550. Suppose if you want to detail about this RTP protocol from the scratch, what is the RTP? So what is the structures are available, payload types are available. So even how exactly we can coding can be done by the between the sender and receivers. So that has been referred. So over the Google, you type just RFC 3550. So over the internet, Google search engine. So definitely we can get back all details about RTP, and RTP packet provides. So that is a payload type and identification. So what type of payload type we are received, we can identify. So I will explain you in the further slides what are the different payload types are available and packet sequencing number. So it is very, very important. So it is a packet sequencing numbers. So which packet has been lost, we can identify very easily. So with the help of packet sequencing number and time stamping. So what is the date and time the packet has been received from the sender to the receiver, we can identify. So again, it is as and when packet is lost, we can identify very easily. So even RTP runs in the edge systems. So RTP packets encapsulated in UDP segments. So basically, so RTP packets are encapsulated. Encapsulated in the sense, so it is not sent openly. It should be sent in a, so that is exactly in the form of encrypted format only. It is sent in the form of UDP segments. So UDP packets like, so because UDP is runs over the internet, so UDP segments like we are sending the RTP packets. Interoperability between, so what is interoperability? We can see that if two voice over applications runs on RTP, they may be able to work together. So that is possible. So again, so voice over applications, it is an internet telephony. So it is exactly runs on the, so there this protocol also. So they able to work together. So this normally we can observe in the session initiation protocol also. So again, session initiation protocol. So it is a voice over IP telephone. It is possible. So again, it is used this RTP so packet, RTP packets. So you can see how RTP runs on top of UDP. So in the next slide, you can see that. So RTP libraries provides the transport layer interface. So transport layer interface has been provided. So as you know that TCP IP reference model, there is a file layers, application layers, transport layer, data link layer, and physical. So there is IP is the network layer, and data link layer, and physical layer. So here, so that is exactly we can observe in the that is file layers in this TCP bar IP reference model. So transport layers. So it is a interface so that extend the UDP. So here payload numbers and IP addresses and payload identification and packet sequencing numbers with the time stamping. So port numbers are it is used with the UDP. So that exactly it is extends. So what exactly the RTP library contains. So these are the things: port number, IP addresses, and payload type identification and packet sequencing number. It is a very useful at the time of packet lost, packet sequencing number, which packet has been lost, we can identify very easily. And time stamping also. So what date and time the packet has been delivered to the receiver, we came to know that from the time stamping. So here, so RTP examples concerned. So what is the rate at which we are sending the RTP? So here, so we are sending the RTP packets from the sender to receiver at the rate of 64 kbps. So pulse coded modulation encoded voice over the, so it is a real time protocol. So has been so as you know that, so it is also already so encoded voice. So using pulse coded modulation techniques, so it is has been encoded. So sending rate should be 64 kbps. That is the sending rate. So application collects the encoded data in the form of a chunks. So chunks are nothing but a group of packets. Example, every 20 milliseconds, 160 byte in a chunk. That is the size of the chunk is. So each chunk, so that is a packet. Chunks is nothing but is a group of packets. So one chunk is 160 byte in a, so that is a size. So every 20 milliseconds, exactly it is a science. So you can, so even audio chunk, so one packet, audio packet, if you say audio packet, so it is a RTP header form, the RTP packet. RTP header form, it is also available. So RTP header, it is exactly, it is embedded, okay. So the IP addresses, as you know that source IP address and destination IP address and source port number and destination port number, it is exactly embedded. And along with this, so even RTP header also contains, so it is a packet sequence numbers and it is a time stamping, so which is encapsulated in the UDP segments. So even RTP header indicates, so what is the type of audio encoded. So even RTP header so also indicates that what is the audio encoding. Audio encoding will be different encoding formats, either pulse coded modulation, PCM or GCM encoded standards they are used in each of the packets. Sender can change the encoding during the conference. So whether it is a audio conference and a video conference, so sender has an option to change the encoding. So that is whether they are encoded in the PCM or it is GSM, they can definitely change this encoding. So during the audio or video conference. So RTP header also contains, already I told, it is a sequence numbers. Even sequence numbers also embedded in the RTP header, as well as timestamp. Sequence numbers as and when packet lost. So it is a very useful to know, so to the receivers, so which packet has been lost. So again, receiver telling to the sender, so again retransmit the same packet. So that is the reason sequence numbers are very useful. Timestamp, as you know that, so what is the date and time? What is that particular session? So particular session, so the packet, RTP packet has been received to the receivers. So as and when sender is sending so audio stream or video stream to the receivers. So next discussion is RTP and quality of service. So RTP does not provide any mechanism to ensure timely data delivery or other quality of service guarantees. It is not given any guarantees. So RTP, it is not given any guarantee or mechanism or not provided any mechanism. So timely delivery and other quality service guarantees. So it is not provide any mechanism. So RTP encapsulation only sent at the end systems, not by the intermediate routers. So RTP packet has been say encrypted way it is exactly sent. So between the end system. So decryptions. So normally sender will always encrypting the packets sent to the receivers. As you know that the receiver RTP packet has been decrypted at the receiver side. So that is so because so to it is exactly encapsulation why you are so it is done. So because of so hackers are many, so our insecure network. So that is the reason RTP encapsulation will be done at so both the end systems. Okay, encapsulation means encryption will be done, and so with the help of some symmetric or asymmetric algorithms. So normally their cryptography algorithm they are using. So as you know that, so again so the receiver, so it is again either symmetric or asymmetric key decryption algorithms are used to convert back into so this encrypted form to so again ciphertext into plain text so of RTP packets. So here router provides the best effort services. So here, so it is intermediate routers not doing any kind of encryption and decryption. So only end systems means sender device, sender RTP packets and receiver RTP packets will do these kind of so security aspects. And router provides the best effort services as intermediate routers. So it is forwarding these RTP packets. So it is a best effort service in the sense. So always given some audio and video kind of is the first. It is a first preference. It is a priority first because it is a not delay. Delay is not tolerable. So up to 400 milliseconds of delay it is a tolerable. So more than 400 milliseconds it is a delay is not tolerable. I think previous such that is discussions are made. So how much of delay is tolerable here. So it is routers will forward the RTP packets. So it is a first priority is given for the multimedia packets. So it is the next intermediate subsequent routers are routers exactly it is follow based on the so shortest path routing algorithm techniques. So making no special effort will do for this RTP packet because so it is arrived at the destination. It is a timely is what matters because it is a urgent packets, audio and video packets. Up to 400 milliseconds of delay it is tolerable. More than that, it is not tolerable by any kind of audio and video. Otherwise, your audio cannot able to hear. Or if it is more than 400 milliseconds of delay it is occurs, your audio so our video cannot able to watch out here. So here next discussion is RTP header. So what is the RTP header format? So RTP header is payload type is available, and sequence numbers and timestamp and synchronization source ID and miscellaneous fields are available. So this is exactly the format of RTP header. So in payload types, that is a 7 bits. So that should be indicate the type of what type of encoding is currently being used. So if a sender changes the encoding during the call, sender inform the receivers. So as and when sender is it is changing the encoding, so even during the call, so it is informed to the receivers via what is the payload type field. What is that? So it is a payload type field. Payload type, it is as you we can understand very easily what is the encoding format has been changed by the senders. Okay, so many formats are available. That is a payload type 0 is a PCM. So with 64 kbps, it is a sending rate, it is a streaming rate by the sender machine, and it is a payload type 3, it is a GSM. It is one more encoding formats are available for 13 kbps, that is audio encoding format. So again, it is a payload type 7. It is identified that we can LPC 2.4 kbps of streaming rate. Again, it is a payload type 26, is a motion JPEG, Giant Pictures Expert Pro. So it is available. Again, encoding type 31, payload type 31 indicates H261. That is the format. Again, payload type 33 indicates MPEG. It is a MPEG format version 2. So video format is available. So these are the payload type. It is indicates the what type of encoding currently being used. That is immediately the sender will whatever changes in the encoding format, so will notify to the receivers. So with the following payload types. Payload types is nothing but encoding format types. So with the type 0, 7, that is the numbers. So integer number will send communicated to the receiver as and when any changes in the encoding format, it is immediately notified with the following payload types of a particular number will inform. So it is understand that, so receiver can understand the encoding format has been changed by the sender. So next is, so here, so there is a one more discussion. It is a sequence. So another format is sequence numbers. Sequence number is a 16-bit. Okay, so it is a format. So incremented by 1 for each RTP packet send. So it is detect. So sequence number, it is a very useful to detect. Already I told, as and when packet is lost. So with the help of sequence number of the RTP packet, so we can able to identify which RTP packet is not received by the receivers. We can identify very easily and tell them to the sender. Again, you retransmit same RTP packet, which is last packet, to the receivers. So and restore the packet sequence. Even we can so restore. So we can able to, suppose if it is any so sequence number, it is missed, so to the receiver, so we can able to restore the particular packet sequence. That is also possible. So that is the reason sequence number is very important here. So next is timestamp. Timestamp field indicates 32-bit long sampling instant of first byte in this RTP data packet. For audio, timestamp clock incremented by 1 for each of the sampling period. Example, each 125 so user seconds for 8 kilohertz sampling clock. So normally, so an application generates the chunks for 160 encoded samples. Timestamp increases by 160 for each RTP packet when the source is active. Timestamp clock is continued to increase the constant rate when the source is inactive. So next is synchronization source ID. It is a field is 32-bit long. It is identify the source of what is the, who is exactly a sender, who is exactly the source. So that ID, so identification we can make with the help of this format. So RTP, who is exactly the sending the RTP stream, we can identify very easily with the help of this field, that is the 32-bit field. So so source ID is IP address, we can easily identify, because that is the reason it is a IP address is 32-bit long. So that it is a, so this SSRC field is also 32-bit long. So who is the sender, we can identify very easily. So that is the reason IP address of the sender we can locate very easily, so with the help of SSRC field. So each stream in RTP session has a distinct SSRC field also. So you can see in the next slide. So I think that's all about miscellaneous fields. Exactly, it is available. So that is so some miscellaneous it is added as a other field. So that's all about this discussion. So in this class, we have discussed about what is a RTP, so what is the basics of RTP and real-time protocol. This is RTP packet header fields we have learned. So that's all about this RTP.